So hello everyone, let us solve LeetCode Weekly Contest 478 first three problems. So the first problem is count elements with at least k greatest values. So you are given an integer array nums of length n and an integer k. An element in nums is said to be qualified if there exists at least k elements in the array that are strictly greater than it. And then we need to return the total number of integers which are like qualified elements inside the nums. So what the question is asking us to find out is the total number of qualified elements. And what is the qualified element? A qualified element is an element such that there are at least k elements which are greater than that particular nums of I element. So how we can solve this question? So one observation is that whatever the kth element would be, or the kth largest element would be, all the elements greater than that particular element can never be qualified element, because if we have a if we are pointing at the kth greatest element, so element after that would be obviously like less than k values. So we can observe that all the qualified elements must exist before the kth largest element. So what we can do, we can just sort this entire array nums dot begin, and we can just sort the entire array. We can find the kth greatest or kth largest element. So how will we do that? Whatever this is, nums of n minus k. So this will give us the kth largest element. Now we will check on each and every element whether this particular element is like less than this kth largest element or not. Now can't we just return all the elements before that? No, because there can be repeating or duplicate values. So we need to check whether the element is like less than this threshold value or not. If it is, we will increment our answer, otherwise will not increment the answer. So let us see the solution. So yeah, these are few like edge cases. If there is k0, so we need to return n, because everything will be larger than. If k is greater than n, because then it is not possible, we need to find at least k, and k is already greater than the total number of elements, then we can't find anything, so we need to return 0. Then we are taking a vector v and we are just sorting it to find the kth largest element inside the like vector. Then we will get the kth largest element. This will be the kth largest element. I have just named it as threshold because above this there will be nothing. And we are just iterating on the entire array, and we'll just check whether this current nums of I is lesser than threshold or not. If it is, we'll increment our answer, and in the end we are just returning the answer. So there was a simple like observation that all the elements after the kth largest element can't be the answer, because we need at least k larger more elements. So after that there won't be any elements, there won't be k elements present. So yeah, this was the simple observation, and based on that observation we have just like solved this particular question. So yeah, so let us just move on to the second problem now. So this is the second problem, maximum substring with distinct start. So you are given an integer, you are given a string s consisting of lowercase English letters. We need to return an integer denoting maximum number of substrings. You can split s into such that each and every substring starts with a distinct character. So what does the question means? So let's say you are given a particular string a, b, c, a, b, d, c, a, b. So this is the particular string that has been provided to you. Now you need to make splits in this string such that each and every like substring start with a unique character. So if you have like created a split here, so it starts with a, so you can't create a split like this again, because this again starts with a, so you don't want that. So you need to split this according to this condition, and you need to split such that the total splits or the total substrings in the end become maximum. So what is the condition in the question? The condition is that every substring start should be unique, start character should be unique. Now we can obviously say that we can always start a substring from any character, like we can make a split here, we can make a split here, we can make a split here, but also we need to consider that we do not make such a split such that the remaining elements substring will again start from a character which has already repeated. Like in this case, it is again repeating from A. So what we can do, instead of splitting like this, we can just split it like this. But again, the B is present, so we can't split it like this. So we will split here. So we will have a starting character A, B, C, and then we will have D. So we will just keep D, C, A, B. So in total we have generated 1, 2, 3 and 4 substrings. So that is how we will do. So how we'll be able to solve this question? So we just need to take care one thing, that we will be always splitting from a unique character, and whenever we find a new character which has not been appeared previously before, we can just like make a split there. So in short, what we can do, we can just count the total number of unique elements, because we can make a split at any new character. So if we can make split at any new character, that means we just need to keep track of the unique characters that we have. So unique characters count we can store. So we will be storing in a frequency vector of size 26,0. So let us take this example AB, which is the first example. So here we have 2 unique characters. So our answer will be 2. So you can see output is 2. But how it is 2? So we can make a split here. So there is one substring and there is one another substring. So yeah, just from the observation of few test cases and like how we can split the, like one observation that we can always make a split from a new character, we can come up with the solution that we just need to like keep track of how many unique characters are there. So in the end we can just return the total number of unique characters. So yeah, this is the code. We are just keeping track of frequency. N is the size of the like string. This is the answer 0. We are iterating on to the entire string to get the count of unique characters. So we are just marking 1 if a character is present. In the end we are just returning the like value of answer which keeps track of what all characters are present. So let's say A is present like this, A, B, A, C, D, A. So initially the frequency of like 0, 1, 2, 3, 4. So this is A, this is B, this is C, this is D, this is E. So initially A will be 0. So when we come across this element, we'll mark this 1. So we'll again come across this element, it is already 1. So yeah, it doesn't matter. We can always again mark this 1. Then we come across B, so we can mark this also 1. Then we come across C, we can mark this 1. Then we come across D, we can mark this 1. Again come to A, we can again mark this 1. So in total we found 4 unique characters. So we'll be returning 4. So that's how this problem will be solved. So let us move on to the third problem now. So yeah, this is the third problem, minimum absolute distance between mirror pairs. So you are given an integer array nums. A mirror pair is a pair of index I, j such that I and j are between the range and j is greater than I. And reverse of nums of I is equal to nums of j, where reverse is nothing but reversing the digits. And we need to take care of the leading zeros as well. So if there are leading zeros, like for example 120 reverse is 0 to 1, so we need to remove this leading 0. So our number will become 21. In the end we need to return the minimum absolute difference between the such indices, which is I, j. And if there is no such pair exists, we need to return -1. So how will we solve this question? So first of all, the brute force approach comes is that we can try out each and every pair of I, j, and we can just try out reversing nums of I, and we can check whether this reverse of nums of I is equal to nums of j or not. And this is the brute force approach, but if you look at the constraints, n square solution will not work. So we need to do something else. Now since we need to find out the solution in O of n times, and what we are doing here, we are repeatedly doing something. We are repeatedly checking the reverse, and then we are checking whether we got something previously or not, or whether we will get something in future or not. So we are dependent on something. So with this approach you can, so with this idea you can try to approach this problem with like by keeping a map which will take care what all elements we have already encountered. So what we need to do, for every nums of I, we need to check whether there is some element nums of j present such that the reverse of nums of I is equal to nums of j. So we need to take care of the future elements. So since we need to take care of the future elements, one thing is for sure that we'll be starting our iteration from n minus 1 and we will go up to 0 until our I becomes equal to 0. So I minus minus. Now what we will do? So what we will do? We will check whether reverse of nums of I is present in our map or not. If it is present, what we will do? That means this reverse of nums of I has some j element. This is reverse of nums of I has some j element which is equal. So nums of j. So we can say that, and if it is, we can just take the answer to be answer equal to minimum of current answer comma absolute value between I minus j. I will show you the dry run for the better understanding, but this is what we will do. And since we need to take the minimum distance, after moving on to this element, we will just update our map from the current element, which is nums of I, and we will store its index. So this is the idea. I know it is not much clear till now, but let us see with the help of dry run so that we can have the better understanding of this problem. So yeah, this is the nums array 12, 21, 45, 33, 54. So we can keep a map and we'll be starting our iteration from here, I here. So currently our map will be empty. So let us say we have created a map like this, which will be storing the current number nums of I corresponding to its index. So currently it is 54. There is nothing inside the map, so there is no element to compare it with in the future. So we can just move forward with our I. But before moving forward, we just need to store this current nums of I with its index. So 54 and its its index. So index is 0, 1, 2, 3 and 4. So index is 4. Then we come across to this 33. So we will check whether reverse of 33. So reverse of 33 is what? It is 33 only. So we will check whether we will encounter in future this 33 or not, and how we will be doing, because we are iterating in the reverse direction for each and every element I. We can check whether we have already or whether we will encounter in future or not. So we can check in nums of I whether this 33 is present or not. So currently it is not present, so we can just move forward. So our I will be here, but before that we need to store the element and its corresponding index. So it is 3. So we are now at 45. So we will again check whether reverse of 45, that is equal to 54, is present in our map or not. So we will check, yes, it is present. So that means these two, like index 2 comma index 4, is a pair that we want to find out. So this is the pair. So what is the distance between them? 4 minus 2, that is equal to 2. So currently our answer will be equal to 2. But yeah, before going to that, we just need to push this particular element also into our map. So current answer is 2 and 45 is stored, and we can just keep it as like the index is 2. So yeah, so now we'll be coming on to this index, which is like index 1, which has value 21. So we will check whether reverse of 21, that is equal to 12, is present inside a map or not. So no, it is not present inside a map. So we will just move forward, but yeah, we will store this particular element inside a map. So this is how it will be done. Then we'll be moving forward. Our I will be here. We will check whether reverse of 12, that is 21, present inside our map or not. So yes, 21 is present and this index is 1. So our answer would be, or the distance would be 1 minus 0. So current index is 0 and the future index that we will find is 1. So 1 minus 0 is equal to 1. So we will compare it with the current answer. Current answer is 2 and the distance that we have is 1. So we will update our answer with the minimum 1. So our new answer will become 1. And this we will move forward. So we will like store 12 with 0 index and we will move forward. Since we reach out of bounds, so we will stop here and the answer we got is 1. And you can see that our output is also 1. So this is how we will be solving the problem. The main intuition behind this problem is that because we need to keep track of elements which will be coming in future and these kind of things of like whether we will have something in future, whether we will have something in past or not. So for these kind of thing, we generally tend to use a hash map. So that is how that is what the intuition is behind this problem. So let us see the code now. How will we do? How will we do with the help of code? Yeah, this is the code. So what we are doing, first we are initializing a unordered map because we don't need the sorted order, so we can make use of the unordered map. Then we are taking the size of the nums array, and we are initializing our answer to be as max as possible. Then we are iterating in the backward direction. So what we are doing, the current nums of I, we are taking the reverse. So how we are doing the reverse, we are just taking each and every last bit and just appending to our number. So how we can do, current number multiplied by 10 plus the last digit. So this is how we are doing the reverse, and we are keep on doing until this n becomes 0. In the end, we are returning the reverse number. So we find out the reverse number of nums of I. Now we will check whether in future we will be encountering this reverse number or not, because we are iterating in the backward. So we can say that whether in future we will be encountering this or not. So if in our map this reverse of num is present, that means yes, in future we will have a jth index whose nums of j will be equal to reverse of nums of I. So yes, we can say that. And if it is, we are just taking the distance of both the elements by index, by subtracting those index j minus I, and we are just comparing with our current minimum answer. And after doing that, we are just updating our nums of I inside our map so that we can have the closest index possible to minimize our distance. In the end, we are just checking if our answer is still int max, that means we didn't find any pair, so we are returning -1, otherwise we are returning the minimum possible answer. So yeah, this contest was pretty much on the easy side. So initially I didn't thought to make video on this contest, but yeah, I just thought of making it right now. So I hope you learned from this solution. Thank you for watching.